Hi everyone, welcome back to the video lecture series on solar and wind energy systems. Today in this video, we are going to discuss about solar and wind energy system, VI characteristics of PV cells in solar resources. Before going to the presentation, here we are going to discuss about VA characteristics of PV cells. Understanding these properties is crucial for designing and optimizing solar energies, and it helps energy maximum, ensures maximum energy harvesting from the sunlight. This is the most important thing, and is adapting for various environmental conditions for effective power generations. So these are the topic we are going to discuss today. Come, let's go to the video. Here, first thing is fundamentals. What is PV fundamentals? So we have four fundamentals: light conversions, silicon domains, and DC powers, and photovoltaic effects. So first, in coming to the light conversions, with the semiconductors device which converts light energy into electricity, and a silicon domain which silicon based cells which holds over 95% of share markets, that we have all known about, that familiar with that. So next is DC power, is generate direct current and output voltage. We generate direct current and output voltage. Here comes next is photovoltaic effect, which is photon exits and the electrons and creating an electric circuits. These are about the fundamentals of photovoltaics. Now, coming to understanding them, VI characteristics. Here comes the VI curve. Here we have VI curve plots current versus voltages. So here the x-axis represents the voltages and the y-axis represents the currents. This curve is in a non-linear key feature and a knee point, destructive key point, and it visually illustrates the all possible operating points for a PV cells. So, reflecting its performance across the variable loads. So, across where we are saying across the variable loads of voltage, current, curve, VI curve. Okay. Now, coming to the graph, this graph represent is drawn between the irradiance, short circuit current, and open circuit voltages. We have an irradiance wave, irradiance graph, short circuit, and open circuit. Here we can see the clear picture of impact of solar irradiance. Okay, here because the irradiance gets slightly increases, irradiance get slightly increases when the current is shorter and voltage is open. Okay. Now coming to impact of cell temperature. So what happens if PV cell temperature get increases? Automatically we have three impact. One is voltage decreases, next one is current increases, third one is power loss. So if the voltage decreases, what happened? High temperature reduces open circuit voltages by approximately 0.3 percentage per degree Celsius and about 25 degrees Celsius. And coming to current, short circuit current, so it increases slightly about 0.05 percentage per degree Celsius. And power loss, so overall power output decreases by roughly 0.45 percentage per degree Celsius. These are the impact of cell temperature. Now coming to key performance of a VI curve. Here comes the key VI curve. Here is an open circuit voltages. When the voltage is maximum, what happens? Current is 0. Voltage is maximum. What about current is 0? If the short circuit current, when current is maximum, what about voltage gets 0 and maximum power point? So optimal voltage current produce highest power. And what is fill factor? The cell quality indicates typically 0.70 to 0.80. And module efficiency, here the maximum power relative to an incident solar power. These are the key performance of VI curve. And finally, we have a real world implementation of MPPT. Here first comes optimize, operate at a maximum power. So PV must operate at the maximum power for optimal efficiency. We need efficiency, high efficiency, if it must be operate optimal. And MPPT algorithm. So MPPT algorithm is essential for producing more powers, and inverter adjustments and yield energy yield boost. So MPPT boost yields about 10 to 30% in various conditions. So these are the real world implementations. Okay. Finally, we are coming to the conclusions. What are the conclusions we have? It is we have conclusion. First one is VI curve. VI curve fundamentals with the essential for understanding PV system and irradiation temperature. If cell temperature get increases, what are the effects? And the MPPT technologies and energy harvesting is under charged condition, changed conditions and reliability installations. So these are the things we have concluded. And I hope you enjoyed this video. We'll meet in next video. Thank you so much.